Assalamu alaikum. Dear students, in the previous lecture, we have discussed about the welding equipments. And after this, we have discussed about the types of welding electrodes, which are further divided into consumable, non-consumable, bare, and flux-coated electrodes. And we end this on the advantages of using flux-coated electrodes. So for today, we are going to end this chapter with a brief introduction about the TIG MIG welding, and after this we will discuss about the aluminium welding of aluminium and copper. So we start from the uh, TIG, which is the tungsten inert gas. Before we start the topic, I would like to show you the figure of the TIG welding phenomena, which you can see in figure 4.16. In this arc welding process, electric arc is struck between non-consumable tungsten electrode and workpiece. So in the figure, it is clear that this is basically the tungsten electrode and this is the workpiece. And this tungsten electron is a non-consumable electrode. A shielding, here the shielding is going to provide A shielding is provided by argon, helium, and carbon dioxide to avoid atmospheric contamination of the molten weld pool. So what is the purpose of the shielding? Its purpose is to avoid atmospheric contamination of the molten weld. If contamination occurs, then the weld will be weak. Filler rod may be used and may not be used. It depends upon our requirement. It is in all position welding technique. AC as well as DC supply can be used. Here we can use AC as well as DC supply. Electrodes used in TIG welding are non-consumable tungsten electrode which vary in size from 0.15 to 9.5 mm. The electrodes are mounted on a special electrode holder which is shown here. This holder is also designed to furnish a flow of inert gas. From this holder, we can also supply the inert gas around the electrode and also around the arc. Welding operation is done by striking an arc between the workpiece and the tungsten. So the arc is developed at this point. In an atmosphere of inert gas like argon and helium, inert gases provide oxidation. So the purpose of the inert gas is to prevent oxidation. The arc is struck by touching the electrode with a scrap metal tungsten piece or using a high frequency unit. So here the arc is produced by connecting the negative terminal with the high frequency unit. After striking the arc, it is allowed to impinge on the job and molten weld pool is created at this point. Filler metal, if necessary, should be added by dipping the filler rod into the molten weld. Figure shows the main parts of the tungsten inert gas welding. So all the previous discussion basically shows the working and the description of each part of the tungsten inert gas welding. Now, what are the advantages of this type of welding is, the number one advantage is that an inert gas may be argon or helium that prevents oxidation and flux is therefore not needed. Heat can be concentrated and a distortion-free weld can be obtained. Clear visibility of the arc, so better control. It can weld in all positions. Heat affected zone is very less. High quality welding of thin materials can be done. And what are the disadvantages? Disadvantages include costly equipment are required. And the second advantage is that non-consumable electrodes is used. Therefore, separated filler rod is required, so output of the work is decreased. Moreover, the process is, however, slow in operation. And the applications include this welding method is used for welding stainless steel, aluminum, magnesium and their alloys, welding of sheet metals, used in aircraft and instrument industries. Now we will move towards another topic, which is the metal inert gas welding. Now this is the figure of the metal inert gas welding. So here it is the job, which also act as cathode. This is basically the arc which is produced here. This is basically the guided tube, and in this guided tube there is a electrode which is the consumable wire electrode in metal inert gas, but in tungsten inert gas this is the non-consumable or unconsumable electrode. And there is also the gas regulator inert gas cylinder which is also moving within this holder. And after this, this is the drive roll, this is the wire reel. Here we can control the flow of wire and gas control. This is the welding power source. Here in this case it is DC, and this is basically the gas flow regulator. Okay, you can easily see this type of phenomena in your daily life. Whenever you are going to go to some welding shop to do some welding. Okay, now we will study about this. In the metal inert gas welding, arc is produced between a continuously fed consumable wire and workpiece. The arc generated is shielded by inert gas like argon, helium and carbon dioxide. About 15 mm of electrode is projected from torch before striking the arc. However, during welding process, torch remain about 10 mm away from the workpiece. The arc length is kept between 2 to 4 mm. The electrode wire is fed from the coil with a constant speed. During the welding process, the torch is kept at an angle of 70 degrees from the horizontal and is moved along the joint in a steady manner. Metal transfer in MIG welding may be of globular and spray type. AC supply is not preferred because of unequal burning in positive and negative half cycle. Generally, DC welding generally DC arc welding machines are used for MIG welding with electrode positive. Moreover, power source with flat characteristic is preferred over another having drooping characteristic, because for same change in arc length, there is bigger change in arc current. Now the disadvantages include the continuously welding at greater speed and in all positions is possible. The process can be easily put into operation. All types, that is thick and thin workpiece, can be welded effectively as no flux is used, so more visibility and neatness of weld is obtained. Now in this table, a comparison has been made between the TIG welding and MIG welding. Try to read it yourself because you have already see the detailed description previously. Now next one is the comparison between the AC and DC welding. We have already seen in detail that with respect to cost, efficiency, heat, energy consumption, maintenance, running cost, wear and tear, shock, distribution of heat, effect on supply system. Over there in the theory, we have discussed this one by one, but here a comparative analysis has been made, which is very good, and try to read it yourself. After this, we have already seen the comparison between the resistance and arc welding with respect to different features. Try to read this also because it is just the drill what you have read in the previous text. Now we will move towards the requirement of good weld. The main requirement of good weld is that it should be free from external defects such as irregular width and height of beads. The weld should have even color, even width of weld, absence of surface defects like crack and surface porosity, absence of internal defects like blowholes, incomplete penetration, and so on. Points to kept in view to avoid weld defects: proper arc length should be maintained, welding current should be selected according to the nature of job, correct welding technique should be used, the electrode of correct type and size should be selected, the joint penetration of workpieces to be welded should be done properly. And the next topic is the welding of aluminium and copper. This is the last topic, and with this topic we are going to end this chapter. Aluminium can easily be welded by gas and arc welding. Aluminium and its alloy have their melting points ranging from 550 to 700 degrees Celsius. At certain temperatures, aluminium forms its oxides and it remains on the metal in the form of thick layer. It is very refractory material, having melting point above 2750 degrees Celsius. Another difficulty is the specific gravity of this oxide is higher than that of aluminium, and it is not removed, then the weld will be weak throughout. Therefore, that said oxide should always be removed using a suitable flux. These fluxes are usually available in powdered form and are mixed in water to form a paste before being applied. So this is the main ingredient of the aluminium welding. In arc welding, this is usually preferred for welding of aluminium. The size of electrode will be determined by the thickness of the metal. Oxyacetylene welding can be employed quite successfully for aluminium and to alloy welding methods. Edge penetration, selection of proper welding rods, and flux depends upon whether aluminium is in the form of sheet, alloy, tubing, and so on. Spot welding is very successful done in aluminium and its alloys because of their thermal and electrical conductivity. The process of seam welding can also be quite successfully employed for this metal and its alloys, but a periodic cleaning of rotating electrodes is necessary due to tendency of the metal to stick to them. And the last topic is the welding of copper. Copper is a good conductor of heat and electricity. Moreover, it is soft, ductile, and tough metal. The deoxided copper is best suited for welding. It is manufactured by adding 0.15% silicon to prevent the formation of cuprous oxide. Similarly, a suitable deoxidizing material is added to the filler rod material for same purpose. Such copper can be suitably welded by most of the fusion welding processes. The high thermal conductivity of copper usually the main difficulty in its welding. Due to this reason, a great amount of heat is required to be produced at the job so as to make good weld. DC having straight polarity is usually employed in arc welding for welding of copper. So for today it's enough, and with this topic we are going to end this chapter. From the next lecture we will start about the basics of the illumination and its type. If you feel any difficulty in this lecture, do discuss with me during the discussion session. Thank you very much. अपना ख्याल रखिएगा. Allah Hafiz.